So now, we know that the slope is f prime of x0, but also we have 2 points. So the slope of AB is y2 minus y1, but let me write A also as x0 comma f of x0. So the slope of AB is y2 minus y1 over x2 minus x1. So f of x0 minus 0 over x0 minus x1. But this is also, as you just told me, f prime of x0. Okay. x0 is my starting point. x0 is my starting point. x0 is my starting point. I want to find x1. This is what I'm after, because x1 is a better solution of R than x0 was. No problem, I would cross multiply. F of x0 equals f prime of x0 times x0 minus x1. I'm after x1, I'll distribute. So f of x0 equals x0 times f prime of x0 minus x1 times f prime of x0. Now, I move this here and divide by negative x1, or I move this here. So let's do this and this here. So x1 times f prime of x0, this is all algebra, x0 f prime of x0 minus f of x0. I'm after this. So x1 equals, I divide by this, x0 minus f of x0 over f prime of x0. And you can say, okay, all this algebra, fine. Okay, what did you accomplish with this? A lot. I started with x0, which was not a good approximation, and I got to x1. So this is the initial value, and this is the first so-called iteration. First iteration, I got x1 closer. Okay, here's what happens next. I'm going to go up exactly how I started. I'm going to go up, create this point, draw a tangent, and determine a new point, which is definitely a better approximation than x1 was, because it's closer to R. If I continue, nobody will see what I'm doing because they're so close to each other. But can anyone at this point, after looking at this formula, come up with x sub 2?
X sub 2 could be x1.
Yes.
F of x1.
Exactly.
F prime of x1.
Exactly. F prime of x1. Can anyone come up with x sub 3?
It would be the same thing as x sub 2.
2 minus f of x sub 2, f prime of x sub 2. Can anyone come up with x n plus first iteration? The one before minus the function at the one before over the derivative at the one before. This is Newton's method. And you can say, how do you apply this? In a minute, we already have an example. We chose the example. In a minute, we are going to analyze the whole thing. Caution. Caution before we start this problem. See here? This is in the denominator. There is no problem here. There is no problem here. What could be the problem here? If this is
0.
Exactly. So x sub 0, make sure, does not make f prime of x sub 0, 0. because if it does, the method we say will never converge. It's undefined. So if I plug in x sub 0, 5, and f prime of 5 is 0, I will never get to x sub 2 because this is undefined. And there is another potential problem. If there is a max or a min between this point that I start with and the actual solution, the method will not converge. Okay, so I'll copy our problem. Arc tangent x equals x squared minus 3. So the question here is, use Newton's method to solve it. I can use Newton's method before I use the intermediate value theorem because I don't have an interval. I can start with the Newton's method. First, like we did with the intermediate value theorem, I have to move everything to one side. So first I have arc tangent x minus x squared plus 3 equals 0. This must be my first or starting point. Then I have to denote this by f of x. This is the function that I have to work with, that I have to put here, and then I have to put here. So the function is arc tangent x minus x squared plus 3. So that's my 15. So f of x equals arc tangent x minus x squared plus 3. I will have to say that is continuous. This is continuous everywhere, this is continuous everywhere, this is continuous everywhere, on negative infinity to infinity. But I have to find an interval and put the endpoints of the interval, and this has to be a 1 unit interval where the function changes sign. Where does it change sign? I have no clue. I have to put in the calculator. So in y equals, clear anything and everything. So Amanda, if that's okay with you, I'd like to record this. So I would like you to turn off your camera because I'm not allowed to record everyone and anyone, and I don't want to. Because I like to record this and post this video in the module. So where is my, okay. So we put in the function in y equals, and I have arctangent. Remember, arctangent is the inverse of tangent, and this is x, close the parenthesis, and then minus x squared, and then plus 3. And then I just give it a shot. I'm going to plug in -2, -1. That's it. I'm done. So f of -2 is a negative number, and f of -1 is a positive number. That's it. My one solution will definitely be between -2 and -1, and that is stated and guaranteed by the intermediate value theorem for a continuous function that changes sign on the 1 unit interval between -2 and -1. Awesome. Now I'll stop sharing for a second. So we are going to write Newton's function. Newton's function is x minus the function arc tangent x minus x squared plus 3. arctangent x minus x squared plus 3 divided by its derivative. The derivative of this is 1 over 1 plus x squared. The derivative of this is negative 2x. And the derivative of this is 3 prime, which is 0. This is what I'm going to put now in the graphing calculator. So I'm going to share my screen again. So I have in y equals, do not delete the function because we need it. So just do a second and insert and put it x, put minus, put parentheses around everything you have because this is the function. Close the parenthesis. And now we're dividing by the derivative of this. You have to be very careful how you enter it. 1 over 1 plus x squared will be 1 divided by parentheses 1 plus x squared and close. And then minus 2x and close again. We have to have parentheses around the numerator and parentheses around the denominator. So I have Newton's function in there, x minus the function over its derivative. At this point, I will exit, second and quit. And then I go to variables. I go to y variables. I call the function. Which function? y1. That's where my function is. So yeah, I say yes, enter. I have to decide, and I'll stop sharing for a second. I have to decide where to start. I can start with my x0 at negative 2, or I can start with my x0 at negative 1. One thing is very important. I have to make sure that my starting point, either negative 2 or negative 1, does not make this 0. So if I put in negative 1, if I start at negative 1, this will be 1 over 2 plus 2. That's not 0. If I start at negative 2, I have 1 over 5 plus 4. That's not 0. It doesn't matter where I start, but I have to choose one. So please choose a starting point. It doesn't matter. But we have to choose a starting point, please. Anyone is with me?
Yes,
Which one?
-1.
Perfect. So I'm back. Good. So at negative, I don't know why it's doing this all the time, but it will disappear. Okay, so we decided to plug in -1 in Newton's function. What does it do? -1 minus arctan f of -1 over f prime of -1. I get an answer. Can anyone tell us what is this number and what does it represent? What did we just determine? We started with x sub 0, which we said is x, it's -1. So what did we determine?
F of
Careful. Yes,
Sorry,
Newton's method, Newton's function at -1 to obtain x sub 1. We plugged in x sub 0 minus f of x sub 0 over f prime of x sub 0 to obtain x sub 1, the first iteration. Good. Here's what I do next with the graphing calculator. I recall with second and entry, but I don't want to plug in -1. I want to plug in the previous answer. Second and answer. Make sure you clear anything else. So when I click enter, what is this new answer that I'm getting?
It's closer to the solution.
This is exactly x sub 2. That's our x sub 2. Let's say we want to stop at 6 decimal digits. Repetition. So we're not there yet. Here's what I do next. Second and copy. And now automatically the calculator will take function y1 and plug in the x sub 2. When I click enter, what am I obtaining now? What is this number?
X sub 3.
X sub 3. Negative 1.428293296. Not ready yet. And then I continue. What is this new number? What is this one?
X sub 4.
Yes, but I will not even copy it because I have 2, 4, 6 digits. Repeating. 4-2 repeats, 8-2 repeats, 9-3 repeats. So the method converged in 3 steps. Since I want 6 digits, 1, 2, 3, 4, 5, 6. This is it till here. There is no point in writing x sub 4 because x sub 4 has exactly the same 6 decimal digits. So this is the answer. That's all about Newton's method. We use the intermediate value theorem to find the interval guaranteed by the intermediate value theorem for a continuous function where it changes sign. Now I have a 1-unit interval and I start either at one end or the other. However, I must check that the starting point that I use, either this or this, does not make the denominator 0. And then you follow the procedure that we just looked at. Any questions?